Okay, so I have a prompt for you today. I want you to go ahead and tell me, think about it for about briefly 15 seconds or so. What do you think A is to make this equation true?
100.
Think about it. A is inside the square root sign. And what do you think A is to make it? You all agree on that?
Yes.
So let's test it. You're saying that A has to be 100. So that means 100, you break it down, you clearly see that it has 10 times 10, right? We have our twins right there. We cross it out, and you have your 10 outside, and that's why we have 10 equal to 10, and it works perfectly. A is indeed 100. So my next question is, can A be negative 100? Will that work?
Yeah.
Okay, let's go ahead and test it out. If A is negative 100, that means inside here, you will have negative 100. If you take the square root of negative 100, what can you get? Okay, wait, so you're saying that negative 100 is made up of negative 10 times negative 10? Is that true?
10 times
Oh, no. Oh, one has to be a positive, one has to be a negative, right? Fair enough. Or some you might even argue and say this, well, why can't I write it like this then? 10 times 10 is 100, times by negative 1, that's negative 100. And I clearly have my 10 outside, right? But I got stuck with this negative 1 still. So there's, what does that mean though? Can you observe and conclude here? What do you notice about having a negative inside the root sign? Can you ever get rid of this negative?
No.
So in other words, can you actually take the square root of a negative number?
No.
No. So because of that, I need to remember that basic rule. If I ever give you, like for example, it looks very promising, the square root of a negative 9. Well, we know what square root of 9 is. It's a 3. But if it's a negative 9, you know very well that you can never, ever have a twins. Won't work. So therefore, if I have a negative as a root, and you try to take a square root of a negative, won't work, huh? Okay? Just remember that. Good. All right, so we know that A is 100. Let's move on to this concept for today. Just one concept anyway. I think it's going to be a quick one. And here it is. I said anti-radical sounds so scientific. Now, what am I talking about? Well, what am I talking about? Anti-radical. Well, just think about this. Just like how we started with, remember I gave you this problem before with 5 plus 2 equal to 7, for example, and if I want to go back to the original, what do I do? 7 minus 2 equal to 5. So, don't you agree that your minus is like the anti-positive? Right? The minus, the subtraction is the anti-positive operations. And just like multiplication is the anti-division. Now, if I have, for example, we talked about this before and hope you still remember it. This is the radical, or more specifically because we're putting this into the square root. What is the anti-radical here? Think about that. How would you get rid of that or undo it?
Square.
Square, very good. So in other words, the square and the square root, they're like mortal enemies. Every time they're together, they'll just cancel each other out. Just like how a minus and a plus, when they're together, like a minus 2 and a plus 2, when they're together, they cancel each other out. You see how it works? So, and the reason for that is because of this. Watch the previous problem again. I have root A equals to 10, right? And we know it's 100. But watch what happened. We have root A, and I said, oh wait, I want to go ahead and access A, but for me to access it, I have to remove this radical sign. Removing, it's like undoing it, and undoing the radical means you have to square it. But we know that for every equation, if we square one side, we have to square the other as well. So if I square it, do you agree that I will have to write square root of A times square root of A twice? Because it's squaring. Whatever I have inside, I have to write twice, right? And over here, 10 squared means 10 times 10. I'm trying to show you step by step. The A is inside. The A is inside, right? So I can certainly multiply them. That's why I have A times A inside a root. Agree? And on this side, it's 100 already. Well, we know that this is a pair, isn't it? A pair, because it's square root. Pair means I can take it outside and also got rid of the root. So to make it short, every time I see a square and a square root, they cancel each other out, and this is my result. I can certainly bypass a step. But at least you know why it got from here to here. Okay? So squaring and square rooting, they're just opposite each other. And that's how we get rid of one or the other. So if I start with a square and say, how do I get rid of a square? How do I get rid of a square? Root it, yeah, square root it. And then vice versa. I say, how do I get rid of a square root? Square it. So just exact opposite. Does it make sense? Another thing that I need to remember for, especially with radical equation, for our lessons today, is just one basic rule. For you to start squaring or getting rid of your radical or getting rid of whatever it is that you need to get rid of, in this case, radical specifically, you need to make sure that the radical is completely by itself on one side. And notice that the reason I can start the cancellation process in this case is because I already have the radical by itself on one side. I shouldn't have anything around it. Think of it as you trying to remove this house and you need to clear out all of the surrounding, you know, like the trees and bushes, whatever. That's kind of like that. Okay? Question here so far. So this is one basic rule. I want you to apply it to every single other problem. And take a look at this problem right here. Where's your house located now? Where's the house? Where's that root? X minus 3. So this right here is where the house is located, right? Remember, you want to remove this house, you have to clear all of its surrounding. In this case, what do you need to remove? Some -2. How do I remove it? Add the 2 over. So if I add the 2 over, I end up with just the house and 6. See that? Now you're ready to do the prime thing, which is to remove it altogether. How do I move the root? Square it, right? So if I'm going to square it, that means if I do it one side, I got to repeat it to the other side. Go ahead and finish it up and tell me what your answer is. Anyone? 39. How did you get that? What will become of the left-hand side? X minus 3, right? Because basically just remove the root. And on the right-hand side?
You have 36.
36. Now, I'm still having students, honestly, even at this point, thinking that 6 squared is 12. Remember, if I want you to get 12, I would write it as 2 times 6 and not 6 squared. So be very careful on that, okay? Of course, and you're right, you add 3 over at the end, and x is simply 39. That's all there's to it. Questions? It's easy, right? Okay. Now check this next one out. Am I ready for clearing the house?
Oh, yeah.
Yes. Then start squaring. Go ahead. Let's do that. I want to see if you recognize anything as you square. I'm just going to start setting up for you here. Of course, if I do it one side, I have to repeat it on the other side. That will cancel out the root, like that. Very good. You recognize that. You do have to box it. Reasons, because it's x plus 3 squared. Because if you have to square that, you got to write it twice. So go ahead and box it and tell me what you have. X squared plus 6x plus 9. Now do you need, anyway, I'll show you the box just in case. Here's the x plus 3, here's the x plus 3. So x squared, 3x, 3x, and 9. That's where I get the 6x from, due to like terms. And of course, for people who wants to skip the box and do it in your head, well, this is how you would do it. You circle your 2 terms and notice. First square, that's give you x squared. Last square, that gives you 9. The 2 circle multiplied double, that's give you 6x. Okay, that's a quick way to do it without using a box. Okay, so that's the right-hand side, and this is the left. Now look, we've got to solve a situation here. From the previous example, if you notice, we have just like variable with single power. But all of a sudden right here, you got variable with multiple powers, like power of second power, first power. So you have like one problem with multiple powers like this. What's the best way to solve this equation?
Square root.
No, you can't square root it now. What is it? What's the best way to do it? Do you recall? Does it involve factoring? Great, you're getting somewhere, but for us to get to that point, what do you have to set up? Combining like term to make what? I know you, okay, I know, but what is it that you're trying to make here? When you combine like term, you have to move things, right? But what is it that you're trying to use here to solve? Well, I know we're leaning to that, but what do you need to make one side equals here? Zero. What is that property called?
Zero product property.
Zero product property. So every time we have like multiple variable with like different powers like this, it's always good to move everything over to one side, solve it for a zero. Okay, so which one would you move over? Okay, so I'm going to move minus x over, right? And I'm going to minus 5 over as well. So I'm going to move these two over. There it is. Let me remove the box so you can see it clearly. There it is. So now, when I write it, this is 0. And this on the right-hand side, I have 5x plus 4, right? You see it? It is written as a trinomial, and like you said, factor it. Factor involving, is there a GCF, 3 terms in a PST, or should we do an X box on this? Okay, so if you say X box, let's do an X box. Here's an X. What do we put up top? 4 and 5. What does 4 add up to? 5. 4 and 1. So we expand that, and we have 0 equal to x plus 4, x plus 1. How many cases do we have here for 0? 2. Now, I'm still having students confused at this step where, okay, what am I going to do from here? Remember, you have 2 cases, split them up and solve for 0. First case, x plus 4 equals 0. It's as simple as that. Second case, x plus 1 equals 0. So I solve for x, I get negative 4 right here and negative 1. Right there. But don't be happy yet, because remember, just like any other equations, it's best to plug it back in the test to make sure everything works out correctly. Watch what happens when I plug in a value to test. Let's say I plug in a negative 4. I'm going to test that one. If I plug in a negative 4, this will become negative 4. This will become negative 4. Negative 4 plus 5 inside is going to be a 1. What is the square root of a 1? 1. Over here, negative 4 plus 3 is a... Clearly, you see that the right-hand side is negative 1. The left is a positive 1. They're not equal. So what does that mean about negative 4? Is that a solution? No. So this one, you call that as an extraneous solution. Okay? And just to be safe, though, I'm going to test out a negative 1 as well. I'm taking negative 1, and I plug it back into x here. And this time, this will give me a 4. Square root of 4 is a 2. So 2 on the left, and this one will give me a 2, so it works. So the negative 1 works, but the negative 4 doesn't. So always check to make sure. Especially when you have like multiple answers like this, one of them could be extraneous, and so it's best to just plug it in and test it. Any questions so far on this problem? Is it easy enough?
Yeah.
Okay, now I want you to go ahead and try this last problem on your own. And it involves a couple of steps. Looks like that. Go ahead. So I have right here 5 times the square root of 4t over 3, everything minus 2. Let me zoom in for you. There we go. Okay, so how do we solve this problem? Add 2, you said. Okay, fine. If we add the 2 over, I'm going to have 5 times. So you notice I didn't put the multiplication there, but you should know that this multiplication equals to 2. Now how do I get rid of the 5? Divide it. So I'll divide both sides by 5. I'll end up with root square root of 4t over 3 equals to 2/5. See? Now the house is ready to be demolished, right? And so how do we get rid of that square root house?
Square.
Square it, right? So if I'm going to square it, I will have what? 4t over 3 equals 2. Now this is one that can tend to throw people off. What is 2/5 squared?
4 over 25.
Very good. 4 over 25. Okay. How do I solve for t?
Divide by.
Okay. Well, perhaps let me remind you here, or refresh your memory a little bit. We have an equation on both sides. We can what? Cross multiply. We can certainly do that. Or, for those of you who like to, remember this is 4/3 times t. The opposite of multiplying is dividing, right? Meaning we divide both sides by 4/3. But we know that when we divide fraction, we have to, when you divide fraction, what do you have to turn the fraction to?
Multiply by reciprocals.
Multiply by its reciprocal. We certainly do it that way too. But so let's do that. If you divide both sides by 4/3, is it the same thing as multiplying by 3/4? Because you have to turn it back to a multiplication problem. And there it is.
Wait, what
Is that a
happens?
4/5?
Oh, there. Sorry.
Yeah.
4 over 25. My bad. When you take 4/25 divided by 4/3, a fraction divided by fraction, what do you do?
Multiply.
And is that correct? Multiply by reciprocal?
Why is there a T?
Because I'm solving for a t. This is 4/3 times t. If you want to get rid of 4/3, don't you have to divide it?
Did you just have to do it the other way?
Or yeah, sure. I'll teach you how to do the other way. Sure. But let's get this done first, and I'll show you the other way. The 4 cancels, right?
Yeah.
Which ends up being 3 over 25. Okay. Now you're saying the other way. Sure. The other way is the cross cancellation. I mean cross multiplying way. You have 4t over 3 equals to 4/25. Right here. Cross multiply involves this. That means you have 100t equals to 12, right? Then you still divide it and divide by 100 both sides. And unfortunately, it's not completely simplified yet, so you got to divide both by
4.
4. So if you divide by 4, guess what you're going to have? 3 over 25 as well. So either way, it'll give you the correct answers.
I like that one.
Sure, whichever way is fine. But there it is. Okay,
Let's say 100T over
100t. This is 100. Divide them up. It's 100t equal to 12, and divide by 100 both sides.
Okay.
Okay. Question on this. We're good? Okay. All right.